In my previous post, we have seen evolution of AI. It started as very basic generative AI, which can answer your questions or provide a summary of text, and over the period, it has evolved into far powerful solution, which is called as Agentic AI. Agentic AI is a system that not only answers, it can execute steps and it can provide output. It actually acts like an agent or a human being. You might be seeing so many posts on LinkedIn about agentic AI. It's hyped to the level that people make you think that building agentic AI needs a PhD. Behind all fancy diagrams and enterprise jargons, it's incredibly simple. If you can write Python code with for loops and make an API call, then you can very well build agentic AI system. So what use case we can start with? Let's take very simple and very standard use case of database query assistant. Many times business users are not expert in writing SQLs. They might just give their requirement in plain English, and what they need is powerful system which can understand that requirement and fetch data from the database. In this video, we're going to build agent using Python LangGraph library, and it would be just a backend for complete solution. So let's get into it. What we are going to build is system that goes through these steps. So it will take input in a natural language. If there is any ambiguity in the query, it will just clarify. And once the query is clear to agent, then it will start ahead with generation of SQL based on the schema and metadata that is available in the database. It will generate a SQL, it will validate a SQL, it will execute the SQL. If execution is successful, then it will return the result to the user. Else, it will go in a retry mode and it will try and repair the SQL. Here intentionally the retry counter is set because we don't want agent to stuck in a infinite loop. After two retries, it will just return back saying sorry, I can't execute it, there is some technical problem. Interesting, isn't it? So let's get started. I will show you how my database looks like. So in my database I have multiple tables, and this table contain stock market open, close, high, low, and different values. For example, one of the main table is EQ Bhav, which has high, low, close, volume. Now let's take a look at Python code. As I mentioned before, I'm using LangGraph library, and LangGraph is very user friendly and easy to use library. It acts like a graph. So you actually create a graph and you give a condition and you define the nodes and you define the edges to tell the sequence. And it has very standard APIs and functions to do that. For example, what we would like to do is we would first like to generate a schema to get the table schema, then generate SQL, execute SQL, and fix SQL. These would be four nodes that would be required for our our agent to work, and these nodes are linked via edges. What makes it agentic is a loop function, because agent needs to be autonomous. It should be capable of validating its output and retry and come up with a solution on its own. And that's what makes a simple program as an agentic. And this is the magic part of this program, where it goes through a retry in case of error. And as I mentioned before, the number of retries is 2 here. Okay, and I can show you some of these functions as well. I am going to upload it onto my Git so you can go and check it. But these are very standard, very simple block of Python code, which actually makes a call to LLM, or they actually uh, read the JSON, or they go and execute the query. As you can see, this particular block is to make a call to Bedrock and invoke a model uh, from Bedrock to and retrieve the answer based on SQL. So this is a fix SQL node which is trying to fix the SQL, and if SQL is wrong, it would make a call to say LLM, foundational LLM, to fix the SQL and execute it again. So let's run it and see how it goes. But before I run, I would just tell you one interesting part about uh, LangGraph. It actually creates a graph that you could visualize, and that helps you make sure your your nodes and edges are connected correctly. So I will just comment out this part and I will execute it to first validate if graph that is getting created is accurate. So let's run this part first and we'll just check the graph. The good part is it provides a graph in a text format which can be visualized uh, using a Mermaid viewer. So we'll just go here and we'll check it. So this is our graph. So it generates the schema, it generates the SQL, it executes the SQL. If SQL is successful, it will end. If not, it will call fix SQL to fix it. Okay, so it's pretty simple, pretty straightforward. Now I'll just uncomment this part and I will run it again. Let's see what it does. And question asked is show maximum close price for each symbol on 2025 0205. So it started, as you can see, it showed me graph, it generated SQL. This is the SQL that it generated. It is going against EQ how table, which we saw before, and here is the output. So it is giving each symbol with its maximum close value, right? Now we'll just try and uh, make it fail so that we'll see how it gets into the second loop of course correction or correcting its own SQL and try and repeat it. So to do that, what I need to do is I will rename this EQ table. So I will say rename table EQ to EQ TMP or back. Okay, so now table is renamed. So when it will fire a SQL, it will fail and it should try to course correct itself. Yeah, so let's run it again. So it started, it generated the graph. I don't need to validate it. In fact, I could take off this step altogether. So it generated a SQL. It's going against eqvow, which is good. The SQL would obviously fail because table is not there. Okay, perfect. So looks like it failed. It retried. Let's see what it did. Yeah. So it generated SQL, it failed, so it went into SQL fixing. It fixed the SQL. Here is the new SQL, uh, and this is an error. Yeah, so in my database, eqvow doesn't exist. So that's brilliant. So I kind of captured the error and passed it back to LLM. And what it tried is, oh, it just thought through and it come up with its own table name. It just thought, oh, the table name doesn't exist, so ideally it might be equity bhav copy rather than eq bhav copy. and it tried again, and obviously uh, after two retries it would stop. Yeah, it again uh, failed, and it's saying replaced this table name with the actual name, which is good. So uh, that's it, guys, and that's how uh, you could build your Gen AI or Agentic AI solution. If you really see, one of the thing that happened here is because we're using Lang chain or LangGraph, it's mostly black box. What it has to do in case of failure, or should it really go and use a different table, all that we can't control at a granular level. So to gain a granular control, we need to use a different method. Also, using a Python for enterprise solution is not a best option. So we need to use a high-end and highly efficient language like Java to achieve an enterprise-grade solution. And that's what we'll be doing in our next video. And we will come up with enterprise-grade solution end-to-end, which would help business users to query data. That's it, guys. So stay tuned for my next video. Thank you.